Today we're going to be talking about z-scores, and our objective is that we will be able to calculate z-scores and use z-scores to compare two sets of data. So this is a picture of the normal curve. It's used in a lot of statistical analysis. The two things we're going to talk about on here are the mean, which this is a lowercase mu. It stands for the mean. It's the symbol we're going to use, kind of like if an M and a U had a baby. And then the other symbol we're going to use is a lowercase sigma, and that stands for standard deviation, which we'll talk about in a minute. So on our normal curve, the mean is always in the middle, and then each line is worth one standard deviation. So this is the mean plus one standard deviation, plus two standard deviations, plus three standard deviations, or minus one standard deviation, minus two standard deviations, or minus three standard deviations.
So a standard deviation is a standardized measurement. And it's telling us about the spread of the data. So if our standard deviation is a big number, our data is really spread out. If it's a small number, the data is closer together. A data set's standard deviation, which are our lowercase sigma, can be calculated using our calculator, and we're actually going to use Desmos for this. So find the mean and standard deviation for the following data set. So we're going to go to Desmos. We're going to click plus and add a table. And we're only going to put the values in Y1. So 4, 9, 11, 12, 17, 5, 8, 12, and 14. You don't need to put them in any specific order. You don't have to make them least to greatest before you start. Just type them in exactly how they are on your paper. Then we're going to move to line 2, and we're going to type mean parentheses Y1. And that tells us that the mean of this data is 10.2 repeated. I'm just going to put 3 of them. 3 decimal places is good. Then to find the standard deviation, we're going to move to line 3. And we're going to click the keyboard icon. We're going to go over here to functions. We're going to choose the stats tab. Now this tab does have mean in it, which we could have clicked for finding the mean when we did it in line 2, but mean is pretty easy to remember and type. It's not a big deal. For standard deviation, we're going to use STDEVP. And then we're going to put Y1 in our parentheses again. And that tells us our standard deviation is 3.937. Oh, sorry, backwards. Coming around it to 3.9.
So a z-score is the number of standard deviations from the mean. So if it's positive, it's above the mean. If it's negative, it's below the mean. So if a data point is 2.5 standard deviations above the mean, what is the z-score? Well, it would be 2.5. If a data point is 1.5 standard deviations below the mean, since it's below, it'll be negative, but the z-score would be negative 1.5. So what would that value be for the data that we just had? Since we're going above or below the mean, we're going to start with the mean. Above, we'll add. we're going up 2.5, and then we'll multiply that with the standard deviation, so 3.9. And when we put that in our calculator, we get that it is 20.07. So same idea here, 10.22. Since we're going below, we would subtract 1.5 times the standard deviation. Again, type it in our calculator, and we get 4.31. So here they basically told us what the what the z-score was. If we need to calculate the z-score ourselves, the z-score formula is x minus mu over sigma. Remember, mu stands for the mean, sigma stands for the standard deviation, and x is the data point they give us. What we can use z-scores for is if something's statistically unusual, if we're not expecting something to happen. This is if the z-score is more than plus or minus 2 from the mean. So if it's more than 2 standard deviations, either above or below the mean, it's statistically unusual.
Kelly's test score on the quadratics test was 95. If the class average was 78 and has a standard deviation of 5, determine if Kelly's score is unusual using the z-score formula. For z-score formula, z equals x minus mu over sigma. So our x is Kelly's score, our mu is the class average, and our standard deviation sigma. So z equals 95 minus 78 over 5. So we'll put that in Desmos. We get that our z-score is 3.4. So, is Kelly's score unusual? Yes, because the z-score is greater than 2.
The other reason we use z-scores is to compare two sets of data. So before we can compare them, we have to convert them to z-scores. So suppose your friend earns an 80% in AP World History and a 90% in Art 1. The average score in AP World History is a 72 with a standard deviation of 6.5. The average score in Art 1 was an 88% with a standard deviation of 3. Statistically, which grade is better? So I'm going to highlight all my information about AP World in one color. So AP World, that's my friend's grade, the average, and the standard deviation. And then I'm going to go back and highlight art in a different color. So since there's two classes, I'm going to do two different z-scores. So for AP World, I'm going to take my friend's score minus the class average over the standard deviation. And then for art, same idea. My friend's score minus the class average over the standard deviation. Then I'm going to put these in my calculator. So 80 minus 72 divided by 6.5 gives me a z-score of 1.23. And 90 minus 88 divided by 3 gives me a z-score of 0.67. So, statistically, AP World is better because the z-score is farther from the mean. It's a bigger number. All right, you have a normal distribution, which is just saying we can use our formula, with a mean of 235.7 and a standard deviation of 41.58. Which data point has a z-score of negative 3.45? All this is a different way of asking this same question. Take the mean. Since the z-score is negative, we're going to subtract 3.45. And since z-scores are the number of standard deviations, we multiply it with the standard deviation. Type that in your calculator, you get 92.249. That's all for today. Fill in your summary, and I'll see you in class.